The action of the modern vertical piano was invented almost 200 years ago. Since then, it has undergone continuous refinement in the search to create a sensitive, expressive, and efficient piano action. Each note must play dependably, and there should be a smooth continuity of touch across the piano. Modern production methods can create a piano that comes very close to meeting the desired standards of performance, but the final adjustments must be done individually on each piano, note by note. These adjustments may require changes of just a few thousandths of an inch in interconnected functions of action parts. This process is called regulation. Fine regulation can only be achieved by understanding the function and relationship of all the parts taken as a whole. Applying rote steps and measurements in sequence will rarely achieve the best results. Fine regulation involves cycles of refinement, making adjustments, observing results, identifying what functions can be improved, and making the proper adjustments to achieve that result. Preparation for regulation involves aligning parts to the strings, checking parts for friction or wobble, and making sure that parts don't interfere with one another. Once this is done, fine regulation can begin. As a first step in regulation, a few sample notes are regulated for optimal function in order to establish standards for all 88 notes. In this video, we will focus on the fine regulation of one note to determine the details that must be considered to give optimal performance throughout the piano. First, let's examine the basic regulation points. 1. The key at rest sits on the balance rail and back rail, pivoting on the balance rail pin. Underneath the key is a wool cloth punching and usually several paper or thin cardboard punchings. These punchings establish the height of the key. 2. At the front of the key, on the front key pin, there is a larger wool punching and usually several paper or cardboard punchings underneath. These punchings limit the downward travel of the key. 3. At the back of the key is a capstan. The whip-in heel rests on this capstan. The capstan can be raised or lowered. It establishes the range of travel of the whip-in from the key, and it establishes the resting location of the jack tip. 4. The jack is hinged onto the whip-in. When the whip-in rises, the jack toe contacts the let-off button, causing the jack to swivel out from under the hammer bud. The let-off button can be screwed up or down to change the moment of contact with the jack toe. 5. The hammer rest rail establishes the rest position of the hammer. This controls the distance of the hammer from the string. It also establishes the location of the hammer butt when the action is at rest. Pieces of felt on the action bracket control the location of the hammer rest rail. 6. The check is attached to a piece of wire that rises from the front of the whip-in. Bending this wire adjusts the function of the check in holding the hammer after it has struck the string. 7. The bridle tape is held by a smaller wire on the front of the whip-in. Bending this wire adjusts the amount of slack in the bridle tape. All of these adjustments work together to drive the hammer to the string and to reset the action to play again. 8. The damper head is aligned and seated on the string by rotating it on the damper wire and bending the damper wire. 9. The damper lift rod lifts all the dampers from the pedal. 10. The damper spoon on the whip-in is bent to press on the damper lever to lift the damper at the correct time in the keystroke. Now we'll examine the action adjustments in detail, beginning with the parts that drive the hammer to the string. 1. Balance rail punchings. The balance rail punchings adjust the height of the key at rest. Keys must be level, and the relationship of the natural key height and accidental key height must be correct. So finding the correct key height implies finding a key height that works for all keys. The key height must fit within the limits of the piano structure, which includes the balance rail and front rail pins, as well as the key slip and cheek blocks. First pass key height may be set by the manufacturer's specification or by estimate based on examination of piano parts and existing key height. Paper and cardboard punchings can be added or removed to adjust the key height. The wool cloth punching covers the paper punchings. A very thick wool punching may produce a spongy feeling in the key movement. 2. Front rail punchings. The front rail punchings limit the dip of the key. The wool punching serves as a cushion to reduce the impact noise of the key in strong blows. The key dip limits the total movement that the key can impart to the action. The relation between the movement imparted by playing the key and the use of that movement by the action parts to play the note and reset must be carefully balanced. Subtle adjustments may be made as the regulation progresses. First pass key dip may be set by the manufacturer's specification or by estimate based on examination of the piano and existing key dip. Manufacturers often provide a dip block to test dip to their specification for natural keys. When the natural key dip is set, the accidental key dip must produce capstan movement equal to the natural key capstan movement. For continuity of function, the naturals and accidentals must produce equal lift to the whippets. 3. Hammer rest rail. The hammer rest rail position is measured by the blow distance, the distance between the tip of the hammer and the point at which it touches the string. In a vertical piano, this distance should be the same for all notes. Adjustments are made by shimming the rail at the action brackets. Blow distance can be set according to manufacturer specifications or by estimate based on examination of the piano and existing blow distance. When the final distance is chosen, the shims must be glued in place. 4. Capstan. The capstan establishes the connection between the key and the whippen. Subtle turns of the capstan raise or lower the whippen. A point of special concern is the contact of the jack tip with the hammer butt. The hammer is mostly supported by the hammer rest rail, but the butt should rest very, very lightly on the tip of the jack. Subtle adjustment of the capstan should bring the jack tip to the hammer butt, but also allow the jack to reset under the butt when the key is released. If a gap is left between the jack tip and the hammer butt, it'll introduce a noticeable tapping sensation to the key movement, limiting control and power. 5. Let-off. As the whippen rises, the let-off button presses the toe of the jack and swings the jack tip away from the hammer butt. The let-off button is adjusted by slight turns of the adjustment screw. Let-off is usually measured by the distance from the string at which the jack releases from the slowly moving action. This may be a manufacturer's specification or by estimate based on examination of the piano and desired performance characteristics. If let-off is too close to the string, the hammer may block on a soft blow, and the hammer may bobble on the jack tip with a harder blow. If let-off is too wide, power and control are lost, and repetition will be delayed by the extended movement of the jack away from the hammer butt. 6. Checking. Checking is measured by the distance between the hammer and the string when a note has been played and the key is held down. Checking can be adjusted by bending the check wire. Checking may vary depending on the force with which the note is played, so notes must be played evenly when regulating checking. Notice that the check wire is a spring which, when pressed, applies force to the whippen. A change in checking can produce changes in other regulation points. 7. Aftertouch. The position of the jack tip when the note has been played and is being held is called aftertouch, and is important to efficient function of the action. It should be clear enough from the hammer butt to avoid bobbling, but if it goes much further, motion will be wasted and repetition will be slowed. Fine performance requires continuity of aftertouch across the piano. Aftertouch is controlled by the interaction of all of the regulation points. Mastery of vertical regulation requires understanding of all of these regulation points to produce even aftertouch. 8. Choices of regulation. A standard vertical action offers a small range of possible regulations. It may be adjusted for gradual wear of parts or to meet special performance requests. In each case, all of the above regulation points must be considered to discover the best final interactive adjustments. If regulation drifts too far from the ideal, the performance suffers. 9. Cycles of refinement. A change of any adjustment point will affect the performance at other points in the action. Whenever one regulation point is changed, it is necessary to re-examine action function at the other points. Fine regulation involves cycles of refinement. Now, let's look at the damper regulation. 1. The damper wire and head must be aligned so that the damper head rests flat on the strings. 2. When the damper lift rod is at rest, there must be a small clearance between the damper lever and the rod. This allows a little lost motion in the pedal and makes certain that the damper heads are pressing on the strings. The dampers must be regulated for even lift from the damper rod before proceeding with individual adjustment. 3. When the playing mechanism has been regulated, the arc of travel of the whippet will be established. The damper spoon will need to contact and move the damper lever within this arc. 4. Standard adjustment calls for the damper to lift when the hammer is between 1/3 and 1/2 of its travel from the rest rail to the string. All dampers should lift at the same point in the hammer travel. This adjustment is made by bending the damper lift spoon. It must be able to press smoothly as the whippet rises and release smoothly as the whippet drops. 5. Notice that the damper lever presses against the whippet when the damper is lifted, but does not press when the damper pedal is pressed. This pressure can affect the performance of the whippet, so after the dampers are regulated, check the full regulation once again to be sure that it plays and resets. Fine regulation can only be achieved by understanding the function and relationship of all the parts taken as a whole. Applying rote steps and measurements in sequence will rarely achieve the best results. Fine regulation involves cycles of refinement, making adjustments, observing results, identifying what function can be improved, and making the proper adjustment to achieve that result.